You know that weather app on your phone? The one you glance at to decide if you need a jacket? Well, it's not just some guess. It's a flat-out technological marvel. Behind that simple 5-day forecast is this incredible story of supercomputers, accidental discoveries, and a relentless quest to predict the future. So today, we're going to pull back the curtain and see how it all really works. To really get why today's science is so amazing, we've got to go back in time. Back to when forecasting was a high-stakes, truly dangerous guessing game. A time when just a single day could be the only warning you got for a life-threatening storm. Seriously, just think about that for a second. 24 hours. That's it. 24 hours to prepare, to evacuate, to try and save your family and everything you own from a monster storm. That was the reality for millions of people, and not even that long ago. It made every single forecast a matter of life and death. I mean, the leap we've made is just incredible. From a frantic 24-hour scramble to a nearly 2-week heads up. This isn't just some small improvement, you know? This is a fundamental change in our ability to see what's coming, and it's all thanks to some unbelievable scientific and technological breakthroughs. So how did we get from there to here? Well, the journey from old folklore, red sky at night, sailor's delight, to modern forecasting is a fascinating one. It's a story that starts with just looking up at the sky and then gets supercharged by a technology that was never, ever meant for weather. For thousands of years, we just looked to the skies for clues. I mean, way back in 650 BC, Babylonians were reading cloud patterns. By the 1850s, we had tools like the barometer that gave us a more scientific approach. But the real game changer? It came completely by accident during World War II. Radar operators, they were trying to spot enemy planes, but they kept seeing these strange ghosts on their screens. This noise wasn't the enemy. It was rain, snow, and sleet. They had just stumbled upon the ultimate weather-watching tool without even trying. Radar gave us eyes, but supercomputers, they gave us a brain. See, modern weather forecasting isn't really about looking at clouds anymore. It's about building a digital twin of our entire atmosphere inside a machine, and then asking it, okay, so what happens next? And the secret sauce that makes all this possible is a concept called parallel processing. Instead of one computer just chipping away at a huge problem one step at a time, a supercomputer breaks it into thousands of tiny little pieces and has thousands of processors attack them all at once. Let me give you an analogy. Think about being at the grocery store. We've all been there, right? There's a huge line, but only one cashier is working. It feels like it's going to take forever. Well, that's kind of like a traditional computer trying to solve a massive problem. But now, imagine 10 more registers suddenly open up. You and a bunch of other people can all check out at the exact same time. The whole process is done in minutes. That right there is how parallel processing lets supercomputers just tear through calculations that would be impossible for any normal machine. And to really wrap your head around the scale of this power, get this, a forecast that takes a modern machine just 15 minutes to run, a computer from the 1960s would have needed almost 600 years to do the exact same thing. That's not just an improvement, that's a complete revolution. So all this insane power, it translates directly into accuracy. Forecasters feed these supercomputers millions of data points from everywhere. Satellites, weather balloons, ocean buoys, and the computer uses it to solve these incredibly complex equations. But here's the kicker. Making that forecast more detailed isn't a straight line. To get from a 3-kilometer resolution down to a much sharper 1-kilometer resolution, well, that doesn't take 3 times the power. No, it demands 27 times the power. It's an exponential challenge. And as amazing as today's technology is, believe it or not, we're already on the verge of the next massive leap forward. So let's look at the 3 major trends that are set to totally redefine weather forecasting by 2030. The future really rests on 3 pillars: computers that are even more powerful, an absolutely unbelievable amount of new data, and the artificial intelligence we're going to need to make sense of it all. First up, get ready for something called exascale computing. We're talking about the next generation of supercomputers that will be over 5 times faster than the most powerful machines we have today. This is going to let us run climate and weather simulations at a level of detail that is just, well, beyond our reach right now. Second, an absolute explosion of data. Seriously, by 2025, the world is predicted to be generating 175 zettabytes of data every single year, a lot of it coming from billions of new internet-connected sensors. And all of that new information, it can be fed right into our weather model.
Now, 175 zettabytes, that number is so massive, it's hard to even imagine, right? So let's put it another way. If you stored all that data on Blu-ray discs and stacked them up, that pile would reach the moon. Yeah, that's the data tsunami that's coming our way. And that, of course, leads us to our third trend, artificial intelligence. Because with exascale computers processing zettabytes of data, human forecasters would be completely overwhelmed. AI is going to be the essential co-pilot, sifting through all that noise to find patterns, spot emerging threats like tornadoes or hurricanes, and flag them for the human experts. Okay, so we've got more powerful computers, an ocean of new data, and AI to make sense of it all. But what does this actually mean for us? Why does any of this matter? Well, the impact goes way, way beyond just knowing whether or not to pack an umbrella. Better forecasts are really a cornerstone of our modern world. They're like an invisible shield that protects lives and property, giving us that crucial time we need to prepare for severe weather. They help farmers secure our global food supply. They allow utility companies to keep the lights on by predicting energy demand. In short, they are one of our most vital tools for navigating a changing climate and minimizing the damage from natural disasters. From ancient cloud gazers to AI-powered digital atmospheres, our journey to predict the weather has just been incredible. But as we get closer and closer to a near-perfect forecast, it leaves us with a really fascinating question. What will we do with that power? Are we truly prepared for the responsibility that comes with knowing the future?